All right, thank you. I'm going to start out using speaker so I don't get hoarse over the week. I'm already getting hoarse as it is. Okay, so this presentation was scheduled for Fort Myers in 2022. Need I say more? So we are re-delivering it. And actually, this project really kind of started at a HEEP conference in Nebraska, was it, when I first started? So yeah, I was walking around the vendor area, getting to know everybody, and I met Adrian, and we were talking about all of their product offerings, and he introduced me to the quadri and common data environment, and I'm like, that's exactly what we need to get. So let's talk about doing a pilot project down in Florida, and let us learn and research and figure out how we can make this happen. So that's probably 2019, somewhere around there. We found a project in District 5, which is just outside of Daytona Beach. It's in the rural area of Florida, although I was just talking to Kevin saying it's not so rural anymore. Everything's growing so fast in Florida. And we started our meetings with Trimble, and we were at about phase 1 on the project. We had just gotten the preliminary improvements to the project, typical section, some of the improvements. Just so you know, the project wasn't a real complicated project. We wanted to start with something small. It was a 3D deliverable. And so it's 2-lane, 2-way with mainly a resurfacing project that we were running. It was one of our pilot ANG projects, or is. And some shoulder widening, some intersection improvements, some drainage. But it had a limited scope. It wasn't one of the easiest projects. It wasn't one of those complex projects. It was probably hit the sweet spot for most projects we had in Florida. And essentially from there, we started having monthly meetings where we were working with the Trimble folks to provide them with the CAD files and define what we call success measures for the project so that I can report to management how things were going. And some of our key objectives were, number one, we needed to take CAD data, put it into quadri, and then be able to view it. And as a design engineer, reviewer of projects and CAD files, a few other people in the room were instrumental in doing a lot of the data validation, right? So we have to make sure that wherever it goes into, it comes back out. We can interrogate, what I call interrogate it. We can check slopes, we can check depths, we can check widths, all that type of things. We can cut sections, we can cut profiles, we can find out if the property data came through properly. We can make sure the GCS is properly located, all the type of things that you would want to do to validate the data. And then we were going to use, or we did use it through the design review cycles for stage 2, 3, and final. And then the final thing we wanted to do was provide the data access into the construction phase of the project, and also for CDIs to inspect all of them. So, we did I think it was prior to the IHEEP conference last year, we did a field visit. Trimble was really supportive and brought in probably $2 million worth of equipment, I swear. They had a mobile LiDAR, they had a total station, they had rovers, they had, I don't know, we had so much equipment. We were there for 2 days and validating the data in the field. And you'll see some photos of where we did that. And all in all, I think it was a successful project for us to learn the capabilities of outside of the typical hardware that Trimble has to offer and the software that they have to offer of this common data environment that can be published up and also work that forward, or work backwards, I should say. Now we didn't, there was some things we did do. I'll hold that for questions because I'm sure you're going to have more questions. And I'm going to let Adrian kind of talk about the data infrastructure around what we used in this project. So, Adrian?
Thanks, Vern. So, for starters, anyone that was in the session just before this, I apologise because you're going to hear me again for another 45 minutes or so. Yeah, just wanted to, so what we really wanted to do here is talk about the technologies that we applied to the 4 and 5 project, the concepts, and then really, like Van said, what we did was an on-site where we took that same digital design data, went out to the site, took all the hardware, pushed the designs out to the hardware, be able to really see what the contractors do with that data actually in the field. So it was really a nice little sort of excursion, if you like. So we're going to one of the first things we also wanted to talk about too is, OpenBIM. We thought that this was really quite applicable to this project and the concepts. So just wanted to put up one slide about that and what those core concepts are, because what we're doing with, what we're doing here with this approach and these technologies, I think are very much aligned with the OpenBIM methodology as such. So, interoperability is a big component, and we're going to talk about the Quadri database and the APIs that it utilises to tie together native software, the database, and then other software that push those designs to the field. The fact that there are open APIs there, reliability, of course, collaboration, so being able to share those designs with the contractor, and I think that was part of something that we felt was received really well, in that having the design team be able to be out on the site and seeing them, not only seeing the designs, but seeing the hardware and software that the contractors are actually using from a construction standpoint, but also from a survey standpoint. Flexibility and sustainability, of course, we're going to touch on those little concepts as well. So, as far as the overview, so Vern actually, this is Vern's slide, so he's already covered that, so we can go to the digital construction technology overview, so the core components that we talked about, what we're going to talk about, and what we applied in the project. If you've seen one of my presentations before, you can see this graphic, because what this does is talk about what we're calling our ALM, or our design to construct, operate, maintain, construction continuum. So we've been building out all of the core concepts and technologies that help really facilitate that streamlined data, translate data from design into construction. And if you're familiar with Trimble, we've pretty much come from the construction arena. We've had contractors using digital designs in our machine control for many years, but they just haven't been getting the digital data in a format that they were happy with or trusted. And the nice thing is about all of these types of events that we're seeing the industry really starting to shift towards being able to understand that the contractors are the ones that hit the ground and they're actually constructing the project. So if we can make their life easier, there's a huge benefit to the whole industry, to the owner, of course, as well, and be able to get to that project that's actually constructed safer, cheaper, and in a more efficient fashion. So one of the core concepts of the Quadri technologies is built around the object-based model. So it's an Oracle spatial database where we translate the design data into objects with properties and geometry. And that's one of the big differentiators between the standard sort of, file-based approach. So we see this as a very, what it does is it really does assist the contractor side of things as well, because what that means is they're able to select, query that data, query the attribution on that data, and then be able to use that as part of the construction phase. The nice thing about those APIs is they are software agnostic, so it doesn't matter what design package you're using. And in fact, because those APIs are far more sophisticated, which is what we're looking at here, they are a far better way of translating that data. So historically what happens is, again, when you bring that data into the contractor phase, there's data loss, there's attribution loss. We're not getting corridor solids, we're not getting the true elements that a contractor needs to actually construct a project. And of course, the benefit of having those APIs there is not only are they bidirectional, but they also let you query what information you want to bring across, and then be able to utilize the best program or whatever you've got experience with. We've got multiple contractors, for instance, that use Quadri just to translate data between, say, Civil 3D and OID. So that's a nice little sort of added benefit there. But again, in the whole scheme of things, you want to get to that digital aspect, and that's really what we're talking about here. So core concept as far as where the data sits, we call it a feature catalog. That's that object-based database. Nice little addition there is we're actually incorporating IFC 4.3 schema into that. And so what that means is those objects in the near future will be conforming to that schema. At the moment, they're conforming to an ISO conforming basically standard as such, which is really what I would define as the next best thing for IFC 4.3. But what that means is when we translate that native data, we associate it with objects according to that IFC schema. How it does that is by what we call conversion rules, and that's something that lets you look at the highly configurable, but we can also use the CAD standards, for instance, so we can templatize that for each state, and what that means is those CAD standards read the information from the native data, translate it into objects, and then it also forms a validation, because if you don't have, if they don't meet any of those, the schema definitions, for instance, or you're actually told about that. So that's a nice little validation component. And pretty much everything you do with the approach here is associated with a task, which is really ties back to the traceability and history of the project, and we'll talk more about that in a second. So what does that actually look like? So, really what we do is we take that data from the design phase, via those APIs, we bring it into the contractor software, which, in this case, is the Business Center. That's the software that they're actually making the data constructible, consumable by the machines. So that may be something as simple as breaking it up into separate components, breaking it up into separate layers, because every contractor constructs things slightly differently. And this is where, again, what we're seeing across the industry is the education towards deliverables as well, because if you can provide something as simple as break lines as components of a surface, then that's what the contractor is able to go and recreate and utilize for their quantity calculations. If those break lines aren't there, then that surface is not really truly usable, and that comes back to the whole concept of them just redoing things. And this is really what we're able to improve here. So then we can push that model out to the field, which is what I was just talking about in our previous presentation, what we're calling the connected data environment. And we'll touch on that, and then be able to capture data back from the field and push that back into the model so you get to this truly usable digital as-built that is not just a pretty picture as such. So some of the tools that we used on the 415 project and part of this process is literally what we're going to talk about now. So Triple Business Center, for instance, like I said, is what the contractors use to make those models constructible, do constructability review. It's something that we're using for many years, using for 3D models. But one of its primary roles originally was to create those models for machine control. It does a lot more than that now, and even within this approach, we're seeing DOT, other DOTs using using TBC as almost like a window to what the contractor is going to see, that data set. It flags things that the machines cannot use when they're constructing. So then those changes can be put back into the designs. So that's tying back to the whole normalization work, for instance. And then as part of the office to field, this is that whole connected data environment I was talking about. So now we've got the machines out there with radios on them, we're able to share designs, and what we're able to do is be able to be more accommodating of issues and changes, for instance. Because of that, in the past, what you had to have done is make that design change, push it out of the business center, save it onto a USB stick, drive out to the site, plug it into the machine, and maybe not even have the right version. Again, with tools here, what we're able to do is not only see where all our machines are, make sure that we've got the right versions. If a new machine comes onto the site, it'll get flagged and say, right, you need to download this version of the design. So again, it all comes back to not only safety, but efficiency. That's the real key benefit of having this office-to-field connectivity. And the same thing applies to controllers as well. So that's what we did when we were actually out on the site. We could push the designs directly to the machines, provided they had either cellular or Wi-Fi connectivity to the devices, I should say, as well, what the surveys are using out there. One of the things another core component of connectivity here, of course, is being able to capture data back from the field. And that's really, again, CMV values, compaction, pass counts, for instance, surfaces for the machines that are actually constructing the project. They're generating those surfaces which we can then overlay on the original design data and get to be able to do comparative analysis between them. So it can be used post, as part of the as-built, but also part of the construction phase 2 for your progress mapping. And this is what the contractors are using. So it's nice to be able to see what they're actually using as they're constructing the project, or at least understand where those designs are ending up. And then visualizing that data in the field. This is what we're going to show some photos of where we had the DOT stuff out there. Visualizing that data in the field. So they're using these same devices, tablets, controllers, where they're able to visualize complex data in the field, they're able to see exactly where they are because of the positional accuracy that these devices are providing, but then also being able to use this as part of the inspection process. These are the same models, the same designs that the machines are actually constructing, and then you're able to interact with those designs. And that's how it comes back to this connectivity, because if you're able to identify issues out in the field, you're able to flag them, assign them to people to go make those design changes, and then keep the whole process moving instead of having machines sitting there idling. Again, environmental impact, sustainability components built into that as well. And then visualization, of course, is a very important component here. So we're going to show this on the actual SL415 data as well. But what this really is highlighting is the ability, once that data is in the quadrant, its objects within properties, it becomes queryable. So then we can query certain segments of it, and that's what a contractor does anyway. They don't need everything, they may just need a road core, or they may, if they're just constructing a retaining wall, they may just need the components for the base of that. Very simple example, but historically, if there's no attribution on those objects, they may have had to go in the past, they've had to go in and figure it out, and in the end, what they end up doing is just recreating it, because by the time they filter through it, they're like, we're just going to recreate it ourselves anyway. The nice component of having that there is we can select that, and then we can take that into the field. I'll have to go back. That's not that. Okay, the video did not translate over. So if you were in my previous presentation, you would have seen a nice little graphic here that talks about, well, actually just shows the 3D visualization in the field of that same data that's stored within the quadrant model. And that's exactly what we were doing out on site with the SL415 team. And then, so that's, again, ties back to the whole visualization inspection, taking that same data to the field, being able to add attribution to it as well is a very important component of that. So now we're getting to the fun stuff about how we applied some of these technologies into the 415 project. So what we did was we brought the source data files were ORD, of course. So we brought in the alignments, the survey data, the AMG existing surface, the proposed surface model. So again, these are all standard DOT outputs as part of the process, and again coming from the DGN files via ORD using the API connection, or we call them connectors, via that API connection into the quadrant database. But as you can see here, we're looking at ORD. It's pretty hard to see there, but there is a design there. And as Vern mentioned, it's a simple project resurfacing job, and you can click through these. There's nice little animations there.
Yeah, that's a 22-mile.
22 miles, there we go. Yep. Keep going.
Can I ask you a quick question?
Sure.
The connector to Quadri, was it reading the alignments and surfaces directly out of the DGNs?
Yes.
Or did it have to do some kind of intermediate export?
So basically, when you've got the connect, what happens is you have Quadri open, and then you have ORD open at the same time, and then there's APIs created by directional link basically between that, or it's a dynamic link. So then you actually query via that task connector, which we'll show in a second, what you want to bring across. You could just bring across the line center line, or you could bring across the surfaces. That's part of the process of you utilizing it. Yes. Yep. So we're still ORD, just looking at the source files here. So again, this comes back to standard survey practice to validate the coordinates, validate the designs that what we're seeing in Quadri and also in the native program are the same. So that's really what we're doing here. There we go. So we're validating those coordinates. And then what we need to do now is bring that into TDC. So what we've done is effectively use the API connection to bring it into Quadri, so that now the object and properties, and then eventually we're going to push it into TDC, of course, and then out to the field solutions. So that's really the process. So what we're doing now is using that connector that we were just talking about. So if we click through, so what we do is we create a task. So we're now, essentially what Quadri does is it installs an extension to OID. That's where it fires up a little create task here. What that does then is effectively loads up lets you then select that data. So we're now selecting the task, choosing the destination task within Quadri. Yep. And then what we're actually then doing is sending those objects across from OID into Quadri via that API. This is exactly what you just asked. So that little drop-down list, that has all of the information you can bring in. So it gives you a list of all that's available, so then you can select what you want. And then the nice thing is, everything you do here is associated with a task, so this becomes part of the history. So you may just bring across the alignments in one part, you may bring across your earthworks in another task. At any time, you can always go back and trace back to those. So now we're looking at that surface within, then we're going to basically query that, we've already selected that. Now we're looking at Quadri, so we've now brought that information in, and we can simply just click through those. Yep. So there's those surfaces, those exact same surfaces that we're looking at in OID. We've now got them with Quadri. Again, back to that validation, let's pick that same point that we just looked at initially and validate the coordinates. So there's the task list, there's the coordinate that we were looking at. So again, just validating that we're looking at the exact same data, so there's no shift in the coordinate system, things like that. Point to note too, within Quadri, whenever you set up a project, you define the coordinate system straight away. That's the very first step. So pretty standard functionality there. So we validated that. We can now start to create 3D views, and we can start to create what we call presentation rules, which are built on the attributes brought across from that connector as such. Now we're just going to visualize that. We can select what we want to, we can publish those 3D views, and then those 3D views, for instance, is where we can start to do click through that, showing the cross-section here. So again, this is where we're now reading all that information, but we're now sitting within Quadri, where we're dealing with those object properties from the source DGN files. And then, if you recall, we want to then send that data to TDC or out to the contractor. So same sort of concept again, we want to use those APIs, but of course we don't want to, we may or may not want to send everything. So let's query that, select what we want to, create a new task. We're selecting the data, we're pushing it into TDC now, or in this case we're creating a new TDC project, so we're contractor software. And again, this is where the nice thing about this, everything is logged. So all of these steps are part of the process, so if something breaks down, we can always go back and figure it out. But remember, because of those connectors, we're getting full corridor slots coming across. So if you just brought in that DGN file directly into TDC, it wouldn't get anywhere near the amount of level of attribution, objects, and detail that we're getting via this process. So now we're sending it out to, in this case, we're just looking at the surfaces that have come across, top meshes, because that's what the contractor is going to be using for their estimating, for calculations of quantities. In this case, we're getting those break lines that I mentioned. Right, so of course it depends on the source design information, but this is the nice part about having visibility to the process, because if those break lines weren't there, then it would just be a surface. You wouldn't have the elements to be able to create that and use what the contractor needs to actually construct it. In this case, we have the alignments, the break lines, the energy surfaces, that finishing grade and subgrade. Because it was a resurfacing job, that's pretty much what we had. Did you have anything to add to that, Vern, as far as additional elements? That was really it, wasn't it? Okay. So then, now we're going to really create these designs ready for machine control. So in this case, we're looking at the source elements within TDC. We're selecting the elements that we want to actually push out. We can keep going through those. And so now we're kind of getting to, so we're talking about business center on the left-hand side, contractor software. we talked about that field connectivity. So, pushing those designs out to the machines, in this case, Works Manager, but then they're actually constructing that project according to, with the tools or the actual technology that's on the machines, as effectively earthworks and site works, that's what they're actually constructing the project with according to that design. So we're going to go through that process here. In this case, again, same thing, we're selecting that information. We're creating, this is what the contractor is actually doing. They're creating a job. They're basically, what we're doing here is creating the contractor, basically the packet or the information that needs to be created to go out to the machine. So in this case, and actually in the previous presentation, someone asked about the technology and the machines that don't have the full capability to read complex elements. This is basically what we're doing. We're kind of breaking it down into core components that the actual technology on the machines is able to utilize to construct a project. If you gave them everything, they would just bog down. Yes, they're computers, but they're not fully, not full PCs here. In this case, we're going to so this is the Works Manager. So again, this is that remote. This is the SL415 project. You can see there's a project boundary in there. So what that means is then when you've got machines on site, as soon as they come inside that boundary, then they get flagged to load up that design. So you've got your calibration, control points, the avoidance zones. So again, those avoidance zones are fed into the machines. And of course, this is all part of the process that what a contractor does when they're constructing the project. So that those machines don't go out to the areas they shouldn't be, and then be able to sync those designs. If we update the design, we can sync it and push it out to the different machines. So this is essentially what we did for the 415 project. So, like we said, not a complex project, but enough to set up the boundary, had the calibration in there, had the different versions in there as part of the process, and that's essentially the same designs that we took out to the site when we were working on that. So now we're looking at the field solutions. So this is screen captures from the actual devices out in the field. So this is where, again, either a surveyor or a contractor is actually using those same designs, they can visualize it, they can use it for field inspection, for staking, for grade checking, as-built survey. So again, what it's hopefully giving you an understanding of is what the contractors are using. And again, these are the same devices that we went out to the site to actually show those designs in the field. And as you can see, we've got imagery there, overlaid on top of that little circle is showing you where you are. And because we were connected to the VRS, we were getting survey-grade accuracy while we're out there. In this case, we're just viewing the surface. And then this is what you're actually seeing in the cabin on the machines. If they're running with earthworks, they're seeing that same surface. As you can see, it's a simplified version, because in this case, it's just an earthworks, either mill or fill, whatever your project is. This goes, you can see where the machine is, where the blade is. And this is, again, all of my tolerances and parameters, so it's just giving you a window into what the contractors are actually using to construct the project. And, one important point to note here, they do get the same 3D visualization. If you go to the next little click there, this is the cabin view. Nice little thing that we see out of this process is, if your designs aren't constructible, or if there's errors in the designs, the machine will actually construct those. In other words, if you click the next one there, what we're seeing here is a little bit of an element in the surface that was an error, whatever you want to call it. If that's not fixed, that will actually be constructed by the machine later. So that's part of the process that we're seeing. Now that would be something that would have gone back to make the design, and would have been in addition to design exception, RFI, whatever you want to call it. But the benefit here is you've got visibility into that process. And that's how we get into the sustainability component, because historically that would have just been fixed over, and then you also would have had a history of that change as well. That's the beauty of having a 3D design throughout the whole process. That change is now part of the history of the project, so if something happened further down the track, you could say, well, actually, this is why this happened. Slide. Again, talking about the intelligent digital as-built, we were able to capture data back from a field. So we were kind of demonstrating this capability when we went out to the site, as far as mobile mapping, but then also capturing data from the field. Because the project hadn't started yet, we were just literally looking at a piece of road. But flight, we had the designs. So as the project is being constructed, however, of course, this is the data that can be captured, fed back into the process, and back into the digital as-built. Progress mapping, of course, so seeing what my earthworks are, seeing what my proposed designs are versus my actual, and that's where, again, we can use drone data, we can use the data from the machines, validate it against the proposed, and be able to see, am I meeting my targets? Do I need to bring additional equipment on site? They're the kinds of questions that the contractors are facing when they're constructing the project. Things to be able to, and then also be able to map that as well. Yep. So we've got those surfaces. As we mentioned, those machines are creating those surfaces. We can overlay that on the design data, and then be able to see where we are, see if there's an area that's over-compacted, under-compacted. In this case, we're just looking at an earthwork surface. But that's the kind of data that has been captured, and in the past, that historically has not been recorded. That's the nice part about this whole process, is we're now starting to really start to add and accumulate intelligence as you go through the whole process. So we've talked about quadri, we've talked about pushing the designs from TPC out to machines, and then being able to use that for surveying as well. So we'll keep going. And again, being able to send that information. So we're now constructing and actually sending that to the machines that they're actually going to construct with. We can go through that. So there's that same surface. Keep going through there. So again, this is just giving you visibility to what they're actually utilizing. When they're constructing it, being able to do those comparative analyses from what was constructed versus what was designed. And then, of course, being able to tie it back to pay items, being able to utilize those same field solutions. And as my previous presentation was with Ron Gann and Infotech, that's part of the industry collaboration that we're doing here as part of this process too, where we can start to tie together essentially high accuracy positioning to the HEEP process as well. Keep going there. So then as far as the digital as-built, so on the left-hand side, that graphic is from the site itself, so we have a drone flight. So we had all that digital data that we just walked through. We can overlay that with the drone data, which can be utilized as part of the as-built as well. We had some underground utilities as well. We had the surfaces. And that's really about it for this project. So like Vern said, it was simple. Go through the process. Next one there. And then, click one more time. So the other, when Vern and I were talking about this presentation, again, we just wanted to mention, what other, or should I say, what other countries are doing as well. They've got a bit of a head start on us. Particular one we'd like to highlight is Norway, which is where Quadri was actually purchased from or acquired from. Here's a project where they've been using digital delivery for many years, where they're actually mandating the use of the technology on all of these, all applicable projects. And these are the benefits that we're seeing. So obviously we're a little bit behind here, but the nice thing is we're starting to put these concepts in play. So in North America, we really are going to start to see some of these cost savings, sustainability impacts. Again, we just really want to highlight that there are projects out there that have been constructed and there are savings and benefits that have been truly realized. So then we get out to the site. So as you can see on the right-hand side, that was just where we had our base, which was literally just a little intersection. That was a dirt road, that part. The main SR405 is running out of the screen here. On the left-hand side is the Triple Business Centre project with that survey data that we were just talking about, the design data I should say, and the little arrows just pointing out where we were. And then so what we did is took those designs out to the field. Here on the left-hand side we're showing what that looks like within site vision. So we have the alignment center line. And this ties, it's a nice little indicator here. If the data isn't 3D, and we understand that it's going to take a while to go through 3D. Even when we were working with the team, we kind of defined this project as like a hybrid 2D, 3D, and we understand that's going to be pretty common as we go full transition to 3D. In this case, that red line didn't have an elevation on it, so it just sat at, it was actually the center line. But that said, the surfaces here in the bottom right-hand corner were now sitting on top. So again, that's the hybrid sort of 2D, 3D component. Again, same thing, this is what we're actually visualizing in the field, using those field solutions, those same designs that we were just looking at. We're actually out there now. When we were out there with the team, we broke it up into separate teams. Everyone was working on different technologies, but utilizing that same 3D design data that we were just walking through. Thanks, Graphic. Same sort of concepts that we had all the different tools out there, surveying, construction. As Vern mentioned, we had a mobile mapping unit out there. So what we really, the goal here was to show how we can take those digital designs to the field and also give exposure to the designers to show this is what the contractors are actually using when they're constructing the project or inspecting. And then in that case, of course, we just had the aerial imagery as well. So that's really it from my side, from the technologies, how we applied it to the project, and then how we actually took that to the field and took those designs and then actually exposed everyone to the tools and technologies as part of that 3D design and digital construction work. And if you've got any questions, we've got Vern here that's happy to answer.
Go ahead.
You're saying Quadri can now get the open roads design and actually make files that we can put into other softwares into the field?
Yeah, so that's
Bentley's working on iModel,
Yep.
working on IFC, and that stuff's 871. I'll never see that. But I'm looking at the point out, if you have a product out there that I can use tomorrow,
Yep.
if I could get the DOT convinced to put in those formats, and what does that do? Normally when I ask for those formats, the engineer will say, well, I met DOT contract. We're not going to do it. Is there a way, is there a special magic formula, secret sauce to get those? Because you're talking about PGN for alignments, you're talking about the surfaces, you're talking about the 3D CAD work, and everything else coming cleanly in, and I can't get anything clean at this stage. So why aren't they promoting it?
Right.
Well, that is exactly what this pilot project was. It was a proof of concept to see if we could go from this CAD environment where we have a data rich and we have CAD standards, the way we deliver it every single time, into an environment where we can serve it up to whatever. And he keeps talking about Trimble equipment. This works with all Topcon, Leica, a bunch of different ones. It'll publish out to that. Now, we wanted it to be, the proof of concept was that, number one, it can happen. I'm trying to talk over the people. Yeah, I guess I should use the mic. The proof of concept was that, number one, we could do it, and number two, we could streamline it so that we could do it on every project. So, obviously, the first time you do it, it's not a magic button. There was catalogs we had to set up, I had to explain to them, yeah, we want it presented this way, this you need to take, and this you don't need to take. It was a lot of work, because there's a lot of stuff we put in CAD files that they don't need that in construction. There's a lot of things, a lot of elements we found out. So we actually went through a process of a crosswalk for them to figure out how to pull these levels out of these files, and it goes into this category. But to be honest, that was one of the beauties, in my opinion, of the Quadri workflow, was that I could set that up and then present it the way I wanted it to, where other tools just present CAD data. And then you gotta know how to navigate CAD data in order to figure out, if you're not a CAD literate person, you have to learn CAD lingo in order to figure out how to display the things you typically want to display. So I'm not sure if that answers your question. We proved the workflow can happen. We now have a swing. The swing is not perfect. The next time we do it, it'll be a lot more streamlined. And we want to get it to where it's a repeatable process. The project comes in, we can export it to Quadri, we can publish it out. If that's the application we choose.
And one graveyard to another.
It works. I can say it works.
I'm a little gray too.
Yeah. All his graveyards is remember.
Vern, just a little bit about your project. So you said it was resurfacing?
Yes.
So you guys milled and
Yeah.
then filled. So did you mill and then capture the surface?
The exposed? the mill surface?
Yeah.
Yes.
And then did you put like geometry on your alignments, or did you just go, you know what I mean, when you do mill and fill sometimes?
Yeah, we've done a few pilot projects for automated machine guidance and milling, and this is one of them. And what we're producing is the brake lines in the design model for milling. And we're asking that the AMG use the brake lines to mill from,
Okay.
rather than the traditional stringline approach.
Okay.
Okay? And then all our projects have typically been constant depth overlays. So then we don't use the AMG to do the overlays because we've got a pretty good surface to start with. We're going to check it just in case. And then we will put the finish grade on or another lift of the overlay. And then eventually we'll check it and make sure everything's in tolerance.
So you use the AMG just for the milling?
For the milling.
Interesting.
So
Okay.
you're milling to a model, not by depth, and then you're coming back by.
Exactly. We're milling to a acceptable slope. That's what we're milling to slope is what we're going.
So the milling machine's gonna cut 2 inches, 3 inches, 4
It
inches.
goes wherever it freaks the contractors out because they're not used to that. They're used to saying, oh, I've got an average 1.5 inch milling, and they're not like, well, that's not match. That is match existing, but we still need to improve it. We need to adjust the slopes. They were built wrong to begin with. Yes.
You're using the DGN file as your data source. Can you do the same thing with an IFC file so it's independent of the authoring tool?
Well, right now, I'll answer it one way, and I'll let Adrian answer it a different way. Right now, we don't have the capabilities to create the IFC files with OpenBIM Design. So we didn't explore that option. Now, maybe in the future, that will be the file translation method instead of DGN. We'll just give them IFC files and let them work with it and validate it against that. But I'll let you talk to your capabilities with IFC.
Yeah, I mean, basically, what Ben said is exactly right. So that capability, I think, will exist in the future, and once the scheme is locked down, technically, yes, you can provide an IFC 4.3, for instance, that will contain that data. And what we're seeing with other DOTs, too, is they provide a contractor packet, and it includes the original signed and sealed DGN file, or DWG, but then they also have another one which includes like a information only. And what we've seen and starting to see more of is an IFC because they've just tested that capability. So obviously at the moment they don't want to sign off on it technically yet, but eventually yes, that would be that's the way ultimately you want to be able to let a DOT to be able to provide a DGN, DWG, and an IFC, and that way any contractor can use whatever they like or most appropriate program.
And just a small point is because the DGN file is its source, you have to have a desktop solution to get the data transferred. If we're an IFC, you could put it in, you're independent, you could extract data from anywhere you need.
Anybody else? Yes.
How, if any, are you pulling in the material data, like the material properties or test results for, say whether it's, your substructure on your pavement or your asphalt mixture design, like, are those material properties and test results being pulled into this data stream as well?
Well, the first part, yes. I was ready to say yes, and then you said the whole thing about the test results, and I'm like, not so much on that. No, anything that we put in the CAD model, we verified, validated that it came across the quadrants. Any of the item type properties came through successfully. Any of the geometry properties came through successfully. So if you were to click on any of those elements, whether you're on a phone or an iPad or on a rover, if you clicked on it and went to the information, it would be the exact item type properties that we put on it in our features, in our CAD scanners.
So those are more like design material properties?
Yeah, they're all design material properties. Now, there are some item type properties that we're leaving open that we want construction to fill out. We haven't gone that far as data rich as I want to yet, but so we were able to kind of test that sort of workflow where they input some data in construction and give it back to us, and we validate that it comes across with OpenBIM. We weren't able to test it in that.
could you pull in like e-ticketing data into that?
Is it actually in here? We didn't test that either. Kyle, you had a question?
Yeah. I love the part where you guys showed the
Picture of
of
me
me.
and my hat.
Yeah.
My Yeti hat. Go ahead.
The picture of I love that picture too. Your heart was a little crooked, but yeah. But that picture of the cat where you can see the triangulated surface, and there was that data point, right? And you're saying like, you know, the blade doesn't know what the design intent really was.
They put that in there. It wasn't really like that.
Yeah.
Our data is perfect.
It seems totally feasible to me with what we're seeing with like Tesla and all the different like neural nets and ChatGPT language models that like we must be very close to being able to pass our design intent to a data set in something like Quadri, where when it is executing the grading of a project, it actually knows what we want it to do. So if there's a bad data point on the surface, it just goes right over it and it doesn't build this stupid thing that shouldn't be there. You know, I feel like that's something we should expect. And
Mistakes are mistakes. I'd rather fix mistakes. I would. I suppose one day we might be able to make it more intelligent.
Computers make choices, not decisions.
Yeah, but you guys are going to witness computers execute design intent better than humans. We're going to see that.
And it's likely that the model had an opening there that we didn't pass the connection detail, whether it was a driveway, like a rural driveway or something like that. We were focused on the AMG for the main line. We weren't doing a lot of driveway improvements. We were pretty much tying to existing, so there was probably some breaks in the brake lines and the surfaces that when we passed it over to Quadri, it retriangulated it and it didn't have that data. It's likely what that was. We had a few of those situations with minor intersections too. I don't know, kept wanting to create models for minor intersections. We found out it was just a category thing where we didn't give you Excel for the minor intersections, the 3D minor intersections. Yes. Hi.
Hey, so in order to use the API, do you have to have the ORD license? Like, Bruce gonna have to buy OpenBIM Designer in order to use Quadri?
As it stands at the moment, yes. Because you have to have both programs open with the APIs running, and then it understands that it can translate the across the
Your own stuff.
Well, let me ask you a question on that. I never really explored that, but if I were to create the export and then gave it to anybody named Kat, could she just then open up Quadri and then import it if I just give her the export from already? Or does it have to both be running at the same time?
So that would be like a traditional DGM import directly into Quadri, and then you don't get the benefit of the API connector in that regard. That would be just a straight, so you may or may not get all the data across. So yeah, that's the pros and cons of having
Is
that.
the same true then if you're operating in an offline mode with no internet connection?
As far as the API, you're basically running on the desktop. So as long as you've got both programs open, yeah, you're not actually trying. You are syncing the data to the cloud for the collaborative component, but when you're running the connector, they're just running on the standard on your computer.
John?
Is there a thought or possibility of setting going from the DGN directory, if it's uploaded to, say, the IML hub, using IML.js connection to pull that data out from the web, instead of being stuck on the desktop? And that's a cheaper license connection. You don't need the CAD.
I mean, that comes down to, working with other partners in the industry. Yes, we have been investigating, the government type of tool data from our model, but at the moment, we can't, but that's the.
I can set up a meeting with Ian if you want. Anybody else? Yes.
When you do the field collection, did you do that all with survey grade equipment, or did you collect some things just with a handheld phone and just receive it?
Well, we haven't gone through the full construction cycle and doing data collection and construction. All of the design data was based on mobile LiDAR that we produced the existing terrain and got the existing linear features from that.
And then when we were out on the site, we were using survey grade for the tools, for the survey equipment, but we also had the site vision out there
David, go
I
ahead.
saw Ashley in the picture there too. How is your construction, DOT construction staff also able to utilize this processing tool to do their job? I mean, I saw that you're alliancing, for instance, with Project and others, and maybe that's part of the answer, but just wondering how we're connecting the DOT construction folks.
Well, from my perspective, we started this journey like several DOTs, a dozen years ago, about we're creating models, we need to start delivering them because they're making plans from our models, and that's kind of gross. And so, in our CAD manual, we have a section of what we call 3D deliverables for contractors. That's a long name, but essentially we prescribe exactly the files we want to all of our 3D projects to deliver in a separate CAD folder. And then those are typically line XMLs right now, because that's our common data exchange, and surfaces, and some DGNs for 2D, just 2D layout, because some can consume in 2D. And then, so that's very prescribed, and we've been doing that, like I said, about a dozen years, so that when CEIs and contractors get our projects that have been delivered as 3D deliverables, they'll have those files to start from. And so then they have to go, all right, I got these files, I'm the CEI, what am I supposed to use to look at these things? And so I'm pretty sure that our department has recommended Trimble Business Center or equal. We don't prescribe it, but we say or equal can read in these files, and then you can utilize this. So for this project, it was to do that. Some of the problems we're having is flags, Trimble flags. I heard it in the last session, Trimble flags, right? And so this project allowed us to kind of go through and make a cleaner deliverable with those 3D deliverables, because we aren't getting enough QC on these 3D deliverables. You know, project reviewers, project managers look at PDFs, and then we give them these 3D deliverables, they don't know what to do with them, so they don't really do a good QC on them. And they aren't considered legal documents. Well, they are now. They are, as of last summer, we said those are now legal documents. You have to look at them, you have to verify them, you have to follow, so that we're getting better deliverables. And so Quadri gave us that ability to do the quality control through the process of the design reviews, because that's what we were pushing, was those 3D deliverables primarily, because we knew that's what they would be using in the field. Not so much the DGN, Open Road Design 3D models, although we did push those, some of them, for some of the content, just so we could validate drainage and minor intersections and 3D cells and all that kind of stuff. Yes.
Once Trimble ingests the data from whatever source, do you have an open API to grant access to it once you have it ingested?
As far as from the design data?
Yes.
So, I mean, I guess what's the question? So you're saying
does Trimble supply an open API to the data source once you have it ingested?
No, so those APIs, they're, I mean, technically they could be open, but we may look at that in the future. At the moment, we control and create those APIs as such. So, like, if there was a program that we needed to create a new one, we would, just because, just to control the quality control as far as those APIs. Further down the track, it may make sense to do that, absolutely. And then just standard APIs, whether or not we open, that's obviously